Okay, so checking out, actually, before I have you try some out, we'll do a few more. So remember when you were doing dissociation equations, it's essentially the same thing as showing the dissolving process for an ionic compound, right? So let's say I had, for example, calcium oxide, okay? So calcium oxide, remember the ionic compound is a crystal lattice solid structure. We are now dissolving it. This becomes calcium ions and oxygen ions. So it's important when you're showing ions, the ions must have the charge written, right? So when it's a neutral compound, right, we don't have the charges, but these are individual ions that are now separated. You must have the charge and the state must match accordingly. Okay, so let's take a look at another approach to this. So remember, if you have multiple ions, you do have to show that in your dissociation equation as well. So let's say we had, let's say calcium 2 fluoride, or pardon me, calcium fluoride. So when this breaks down, we have calcium ions, of course, but there are 2 fluorine ions that are produced from 1 calcium fluoride. So that must be shown. Essentially, it's almost like you're balancing out this reaction. You can't have 2 fluorine on one side and all of a sudden it only makes 1 fluorine. Okay, so give these 3 a try. So we have aluminum phosphate, sodium nitrate, magnesium chloride. So remember, you're writing out dissociation equations for this. So pause the video, give these 3 a try. Okay, so let's take a look at what we should have here. So aluminum phosphate should be AlPO4. So remember that charge balances. We have +3, -3. So we have aluminum ions and phosphate ions as a result. Okay, it's already balanced. Sodium nitrate, so we have NaNO3. When that dissolves, we have sodium ions and we have nitrate ions. And then, of course, magnesium chloride. We have 1 magnesium ion and we have 2 chlorine ions. Okay, so in general, how will you know if something is able to dissolve? Okay, so first of all, in a polar solvent, most ionic solutes are able to dissolve, and of course polar molecules, because like dissolves like. Now, for ionic compounds, you do have to check the solubility table, because remember that some ionic compounds have high solubility, some ionic compounds have low solubility. So even though all ionic compounds can dissolve at least a little bit, some are able to dissolve a lot, like very easily, and some only a smaller quantity is able to dissolve, has lower solubility. Okay, and then of course non-polar solutes are only able to dissolve in a non-polar solvent. So remember, when we're referring to the molecules, we're talking about things that share electrons, right? So non-metals only. Ionic compounds is when we're dealing with our metal, non-metal compounds.